Okay. All right, gentlemen. So welcome. Let's see. So as far as announcements goes, there's no real major announcements. We're at the end of week 5, right? So we had exam 1 over the weekend. Hopefully everyone has, is making their way through our assignments. If you have not gotten access to Pearson, you just have to do the best you can. You just got to be careful because this stuff piles up quick, and it's going to start to increase in difficulty. And I feel like the information is not too challenging, but it is a lot of information. It's information overload. So it's like, just be careful about letting this stuff pile up. You want to try to stay on top of it as best you can. And then also, hopefully just be sure that, you've connected with Dr. Lamar and that you're doing the lab component of this course. Basically, you just follow her instructions, and she'll give me a grade for each student at midterm and at the final, and I'll use that grade to update. I'll scale it so it's 10% of your grade. So, you know how that goes. Also, a PDF copy of anything that you see me writing is available on Blackboard in the box link section, in our notes section. And so every time we meet, anything that you see me writing, I pretty much load it as soon as we end the session. At the end of the session, I load it and make it available in Blackboard. So today, I would like to go through as many of the homework questions together as we can. Let me get back to you guys, of course. And I'll check attendance again in about 10 minutes to get the stragglers. This is what, 3 p.m. And this is 1.4. Okay. All right, this question asks us to write a linear function that has indicated values and sketch the graph. Okay, so let's say we're getting a copy. Sorry. Okay, we're going to take this and drop it here. Okay. So working with a linear function, at one point we said that there are 3 formulas that we want to have ready to go when we work in linear functions. I've noticed that we've kind of been able to get through these using 2 main ones, which is the slope formula and the slope-intercept formula. So let's go ahead and get a copy of the slope formula. One of my instructors would say every time you use a formula, write it down. That constant repetition of writing the formula ingrains it in your memory. So, whatever we do the longest, we do the strongest. Whatever we practice, we get really, really good at, right? So, Okay, so slope formula, y2 minus y1 over x2 minus x1. Again, this is our slope. And then we're also going to finish in the form, the slope intercept, which is y equals mx plus b. Okay. So now let's identify the ordered pairs that's given. The first piece of information says that when x is 0, y is 9. And then when x is -9, y is 0. Okay. So one thing we can acknowledge here, and I usually like to label it x1, y1, x2, y2. Okay. So then if we wanted to find our slope, our y2, 0 minus 9 over -9 minus 0, -9 over -9, which is 1. Okay, so we have a slope of 1, and then we really are usually trying to find the y-intercept, but they gave us the y-intercept in this one. So our b is 9. They just happen to give us the y-intercept in this one. So then if we put these two pieces of information together, our linear function is going to be m times x plus 9. Let's see if I can. Nope. I don't know why I keep doing it. Okay. And then, it's a good idea to confirm that our original information works in our model. So when x is 0, notice that the corresponding y is 9. When x is -9, the corresponding y is 0. Okay. So we got x plus 9. Here. X plus 9. Okay. See the time. I'll check on the attendance in basically around 3:15. So then our y-intercept is 9 and our x-intercept is -9. So that has a positive slope. I think the only one with those conditions is going to be C. Okay, let's try the next question. So this one's similar. So let's go ahead and get a copy and pretty much do. Let's see if something different happens, even though it's the same setup. Okay. This is kind of interesting as the instructor though, because oh, okay. I think we lost our screen. Start the broadcast. Come on. It's interesting as an instructor because okay, so we meet twice a week. So today's Wednesday. When I'm done with you guys, I'm starting my weekend. But it's okay. Okay. So let's do the same thing, right? So and let's see what happens in this case. So our slope y2, come on, minus y1 over x2 minus x1. Again, this is our slope. And we want to finish with the linear function, f of x equals mx plus b. Okay. Let's identify the order pairs that are given. When x is -1, the corresponding y is 3. When x is 2, the corresponding y is 9. And then let's label these x1, y1, x2, y2, right? So if you look at this one compared to the previous one, our steps are essentially the same. We're just accounting for the changes. Okay. So let's start by finding the slope between these 2 points. Our y2 is 9, y1 is 3, x2 is 2, x1 is -1. So on top we get 6, on bottom we get 3, so that's 2. Okay. They did not give us the y-intercept this time, so we need to solve for the y-intercept. I feel like the first order pair might be a little bit easier to use, so I'm gonna work with that one. Okay, so our slope is 2, our x is going to be -1. We're trying to solve for b, and our y is 3. Add 2 on both sides, b equals 5. So then our claim is that our linear function is going to be 2x plus 5. And it's a good idea to confirm. We can delete this. Copy. And it's a good idea to confirm that the original points work in this guy. Come on. Come on. There we go. Okay. So then notice when x is -1, we get 3. So the first one checks out. When x is 2, we get 9. So this one checks out as well. Okay. We got 2x plus 5. Let's go answer the questions being asked. And I'll check a 10. No, we're still a little bit down. 2x plus 5. That's x. 2x plus 5. Okay. Okay. Oh, and then the graph. So our y-intercept is 5 with the slope of 2. A has the wrong slope. It can't be A or D because those both have negative slope. And it can't be B because that has the wrong y-intercept. So it should be C. Okay. All right, let me get, I know we had a couple of people in the waiting room. Let me check on them. Oh, let me stop sharing the screen. Okay. He was here. I guess he got put in or something. It's fine. Okay, sorry about that, guys. All right, so let me go back. So we're just making our way through as many homework questions as we can. All right, so this question is asking us to find the intervals over which the function is increasing, decreasing, or constant. So this one I would suggest just look at the graph, right? We see that the highest exponent is a 1, so this graph should be linear, just a straight line. We can also see that the y-intercept is -1 and it has a positive slope, right? So if it has a positive slope and it's just a straight line, that means it's increasing over its entire domain. But it's never decreasing, so it should be this one. The function is never decreasing and it's increasing. The domain of a line is all real. Sorry, guys. Negative infinity to infinity. Okay. Constant is never constant, so it's never flat on this in this example. I find the intervals over which the given function is increasing, decreasing, or constant. Now this one we have f of x equals 4x squared, right? X squared is going to be a U-shaped graph, right? Now the leading coefficient is positive. That means the right-hand side does the exact same thing. Anyway, that's transformations. But here we basically have a U-shaped graph that opens up. So then if we think about a parabola, and we can look at the graph. Let me see if I can. Okay, I might need to make another one. Okay, I think we're okay there. Ooh. Okay. So I just wanted you to see this, right? So then 4x squared. So when we look at the graph of this, right, it's decreasing on the left-hand side of x equals 0, and then increasing on the right-hand side. All right. So this is increasing from 0 to infinity. I'm going to go with A. We don't need this one. And then it's decreasing on the left-hand side, which is negative infinity to 0 in this case. And it's never constant. Oh no. Start to share. Cool. Share the screen. All right. So this question is regarding identifying a function as even or odd, right? So we had, I think, about 3 different ways to express a function as even, and we had 3 different ways to express when a function is odd. One way is pictorially, is looking at the graph. An even function has y-axis symmetry. So that means if you cut along the y-axis, one side is going to match, be a mirror image of the other. Origin symmetry, a function being odd means it has origin symmetry. One way to visualize origin symmetry graphically, if you like cut along the x-axis, put your thumb on the origin and rotate the top half to the bottom by 180 degrees, those 2 halves should match up. That's origin symmetry. Another way, let's kind of get into the way that this one is asking us to do it. So with this one, we're going to apply, well, I guess the second way is, like for instance, when a function is even, whenever we have any point x comma y, we're also going to have it's another point which is negative x comma y, right? So what they're doing is basically whenever you get a point on one side of the y-axis, in this case, you also get a point on the other. So we're going to have y-axis symmetry, which means that this function should be even. Wait. So when we look at this one, if you look at the first point, you got negative 100 and negative 90. And if you compare that to the one on the far right, both the x and the y have changed. And I think if you kind of keep comparing the points, like negative 10 and 10, negative 1 and 1, both the x and the y are switching signs. So when both x and the y are switching signs in this context, then that's going to be an example of something that is odd. Okay. All right, let's try this one. So similar thing, if we look at the first compared to the last, I think they're both switching the whole way. So this one should be odd. All right, so the first way we had to determine whether a function was even or odd, even was y-axis symmetry, odd is origin symmetry. The second way we looked at like given any point x comma y on our graph, we compare it to either reflecting about the y-axis or reflecting across the origin, right? So if it's even, then whenever we have x comma y, we also have negative x comma y. And if it's odd, whenever we have x comma y, we also had negative x comma negative y, right? I know those two sounded very similar. The difference is very subtle, but this one is applying a direct application of the definition of what it means for a function to be even or odd, right? So let's start by getting a copy of this, and let's take some quick notes. I'm totally like, I don't know. I'm really sleepy. I was up. I'm just up at night. Like I get up and I can't go back to sleep. So at this stage of my life, I stopped trying to force myself to go back to sleep. I did that for about a decade, trying to force myself to go back to sleep, get 8 hours, and it was torture. I mean, I was laying in bed, just laying there, like like awake. So the error, I get this question set up. Come on. There we go. All right. So determine algebraically, right? So let's start by pulling a copy of the definitions of what do we mean by function being even or odd. So again, even, oh, come on. Every time I go to write it does this. An even function is going to take on the form, when we evaluate f of negative x, we get back to the original. If this happens, that means we say the function is even. The definition of a function being odd means when we evaluate f of negative x, we should get negative times the original. Like audibly, those sound the same, but the difference is like kind of hard. It's subtle, right? But then when you write it out, then you can clearly see the difference between these two functions, okay? So what we're gonna do is replace each x with a negative x, simplify and interpret our results. So the first thing I like to do is replace each x with a blank set of parentheses. So then we have this g of x equals 2x cubed plus 7. Okay. So then into the blank parentheses, we're going to put negative x. Right. Okay. So now, terms are things that are added and subtracted. Factors are things that are multiplied, right? So there's only one main grouping symbol. So this is one term. This is another term. Okay. So then here, if we say negative x cubed, we have negative x multiplied by itself 3 times. Is that final result going to be positive or negative? Right. That's going to be negative. Okay. So then let's do it like this. 2x cubed plus 7. Then we ask ourselves, okay, is this the original? All right, then we should say no. And I think even if we factor out a -1, we can't get back to negative times the original. Let me think about it. So this should be an example that's neither even nor odd. Halfway? Thank you. Yeah, like I get like the itis every week, especially on Wednesdays, because there's a part of me that's just so geek. Like my weekend starts as soon as I let out my next class, which is like 5 p.m. So I'm just like, that's all I'm thinking about. It's like I can go do whatever I want my time. Okay, so we're gonna put it as neither and check the result. Let me check on Zoom. You guys are awfully quiet. Let me see what's going on here. Okay, the chat looks clear. There's no worries. Let's keep it moving. Yeah, let me write this one out. I didn't write this one out from my early roots. I was like, well, let me get this one to go. I just did it and just kind of explained it, but I was like, well, let me see if it's a different experience if I write it out. And then this guy. Okay. Come on. Okay. So again, if we're going to determine this algebraically, let's start by getting a copy of the definition. So a function being even. Whenever we evaluate f of negative x, we get back to the original. A function, the definition of a function being odd, whenever we evaluate f of negative x, we get a negative times the original. Sorry, I kind of ran out of space there. And usually I like to have this pop a little bit. Okay. So then let's pretty much do the same procedure with this example that we did with the other. I'm going to give myself a little bit more space. So first thing is we're going to replace each x with a blank set of parentheses. So we get this f of x equals x to the power 7 plus 5. X to the power 5. Okay. What are we plugging in? We're plugging in negative x for each term. So then if we do this, the first term has an odd number of negatives, so that one's going to stay negative. Same argument for the second term. Okay. And that needs to be a 5. Is this the original? We would say no. So let's try factoring out a negative. Oh, okay. Yeah, we're factoring out the negative. So then this is going to be plus. So is this negative times the original? X to the 7 plus x to the 5? Yeah, all right. So we started with f of negative x, and we showed that that's equivalent to, in this case, f of x. When we have that happening, we say this is even. In other words, it should have y-axis symmetry. Okay. Let's see, that one we got even. Wait a minute. No. Sorry. Yeah, I told you I'm drifting. This is negative times the original, right? So that means that this is odd. Okay. We're totally about to get that one wrong. See the time. Okay. Oof. All right, this looks like a good one. Determine algebraically whether the given function is odd, even, or neither. Okay. So let me start by getting a copy. All right. We again just start by getting a quick copy of the definitions. And odd. We evaluate f of negative x, we get a negative times the original. Okay. So then, like we did with the others, we're going to start by replacing each x with a blank parentheses. Okay, and then we're going to replace each x with a negative x. Okay. That's the first term is going to be positive, positive. So on the bottom, this guy has an even number of negatives. So it's going to become positive. So it's just going to be 8x plus 9. Notice everything here is positive, but the original, let me see. Right, because this is not the original. And if we try to factor out a -1, we can't get back to the original. So is this one? This is an example of something that's neither. Okay, so we got neither for that one. It's 333. So it says the graph of a function is given to the right. Use the graph to find each of the following: the domain and range. Let's start there. So the domain is going to be the very left to the very right. So the very left is when x is -2. The very right is when x is 9. And since we're doing domain in this context, we can use a square bracket. We're going from -2, I think it's to 9. Okay. Yeah, -2 to 9. Very left to the very right. And then the range is the very bottom to the very top. So -2 up to 3. So again, the range is the very bottom to the very top. Okay. X-intercepts. So to find the x-intercept here, we need to find the equation of the line through those 2 points, and then use that equation to answer the question. All I need is the -2, -2, and then 4, 3. Okay. -2, -2, and then 4, 3. Okay. We want the equation of line. So x1, y1, x2, y2. We usually like to find a slope. Over x2 minus x1. And then also, we want to have a copy of the slope intercept. Okay. And let's find the slope. It's going to be 3 minus a -2 over 4 minus a -2. 5 over 6. So this is our slope. I'm going to use the second point to solve for my y-intercept just because it looks a little bit lighter. So then I take my slope x value is going to be 4. We're solving for b right now, and our y is 3. Okay. So then ultimately b is going to be, that becomes what, 2 over 3? So 10 over 3? 10 over 3. Okay. If you put 27. And then it looks like that boils down to 17 over 3. Okay. We can check it before we submit it. Let me see. So we're getting that our linear function (5 over 6) plus 17 over 3. Okay. And then we just want to check, we just want to check and make sure that the original piece of information works in here. Okay, come on. All right. So let me see. I don't even feel like checking all that. I'm just gonna kind of jump to the answer. We're almost out of time. So if I want the x-intercept, I set y to 0. Okay, I would subtract that and then divide. So it's the same as multiplying by the reciprocal. That's a 2. Looks like 22 over 5. Let me try 20. I think it was 22 over 5. Let me just try that. Let me write it out. 22 right here. If you set that to 0 and solve, you subtract and divide. Let's try negative. Wait a minute. What is the question asking for? Intercepts. Let me check again. I feel like I'm doing something wrong. Because if you subtract, if you subtract that and then divide 6 over 5, so then that becomes 2 over 5, 34 over 5. Okay, let's try 34. Let's try 34 over 5, sorry. Come on. 34 over 5. Okay, let's see if that works. Better get it wrong. Let me check one more time. -2, and 4, 3. Let me see. -2, and 4, 3, right? 3 minus a -2, double negative is positive, that's a 5. 4 minus -2 is a 6, so that's our slope. Y equals mx was 4, our b was 3. I mean, our y value was 3. That becomes a 2 over 3, 10 over 3. Oh, I see what I did wrong. I just ignored the 3 on the right-hand side. Okay. So I'm just gonna put a strike through all the part that was wrong and then pick up from there. Part of that is just because I'm really sleepy. All right, that's wrong. I'm gonna leave it though. And let me pick up here because I went, that's where I made my mistake. I was right after here. Let me copy, let me paste, and I know we're about to get out of here. 2 over 3, 10 over 3. So then 27 over 3 minus 10 over 3, 17 over 3. Okay. So we got this for our y-intercept. All right. So then we get what? F of x 5 over 6. Okay. We're trying to find the x-intercept, so we set y to 0. All right, let me just write it like this. 5 over 6x plus 17 over 3. We're setting y equal to 0. And again, I'm not checking this. I'm trying to just wrap it up. If we subtract and divide, we'll get x equals, we're going to have this negative 17 over 3. Dividing by 5 over 6 is the same as multiplying by 6 over 5. Okay. This 3 turns this into a 2. That's a negative 34 by 5. Negative 34 by 5. Let me check my graph real quick. Let's see, that looks positive. What am I doing wrong? I think I'm about to get this wrong. I'm like out of time and I'm like asleep. XY. Let me check my slope again. That's a 5. That's 6. That's what we had before. Okay, so maybe that's not where the error is. Yeah, I did it twice. Okay. Let me think for a moment. When y is 0, you subtract and divide, you got it here. Negative 17 by 3 times 6 over 5. That turns that into a 2. Then we try a negative 34 by 5. Come on. Oh, I think we forgot to put our negative. Yeah, see, I'm totally tired. Let's see if we can get this in. It's our last chance. If we don't get it here, then I think we, come on. I'm gonna have to retype it. Negative 34 by 5. Okay. I guess I'm just not confident in that because you can see that it should be positive. Let me see. I'm trying to find this error. Positive. That's not the right y-intercept. Because that's like 3 2/3. That's where we're making our mistake. 27. If you divide, that turns that into a 3. Turns that into a 2. 10 by 3. Subtract. It's positive. 10 by 3, let me think about that. Yeah. Yeah, I'm not sure what I'm doing wrong. I hate to do this, but I'm out of time and I'm like dozing. I'm gonna just make this positive and submit it. We're gonna have to take the L. So what are we doing wrong? We have to, there's something that we don't have right. Let me see. -2, -2, 4, 3. Let's see, am I looking at these proper? Did I put -2? Yeah, 4, 3. Is it 4, 3 or is it 3, 4? It's 4, 3. Let me see. Let me do it one more time. The slope, that's a 5. And that's 6. X is 4, Y is 3. I was simplifying. Let me do it here on the side. I see the time. I'm getting you guys out of here. If I do 3 minus 5 by 6 times 4, a -1/3. Why am I not getting that when I did the other thing? Minus, Let me check it down here. Over 1. 3 times 3 is 9. I did 3. Okay. Finally got to the bottom of it. It was driving me nuts. I was like, what am I missing? Right here. Because I told you I was dozing. When I converted from 3 to an improper fraction, that's where I made the mistake. All right. Because that's supposed to be a 9 right here. This is supposed to be 9 and not 27. Then that's where it was falling apart. And I did it twice. Okay. So we're out of time. But at least we found the mistake. Moral of the story: get some good rest before you do math. Get some sleep. This is why I don't do well being on call, because like when I'm tired, there's nothing I can do until I get some rest. I do the best I can being drowsy, but so we're gonna have to chalk that one. It is what it is, but I'm glad at least we got to the bottom. We figured out what we were doing wrong. Me trying to do stuff in my head while being those sleepy is the culprit there. Are there any questions? I'm gonna go ahead and load this to Box just because it's okay. But if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, stay dangerous. Peace. All right, guys.